All right, so to get started, our first step says prepare a solution of anthocyanin, a natural dye. So to do that, we have to add 1 big spoon of anthocyanin, which is like a red, purpley, pretty kind of colored dye, to our plastic cup.
Mommy,
yes?
can I do the dye?
I will be taking questions at the end. Yes, Isabel, you can come and do the dye. So I will pour it and you can put it into the cup. So Isabel is my first assistant. So come by Lily.
Okay. Wow, that's a good dye. Do we need water in it?
Not yet. We are following the instructions step by step. So the first step says 1 big scoop. That's a pretty big scoop. Now dump it into the cup. Whoop. Good, very good. Tap it on the side. See if you can get some of the other stuff off. Good girl. All right, now put it back on our tray. Nice job. Whoa, the wind is a factor in this one. Gotta be careful there. All right, then we're gonna add 20 mils of water. Oh darn, we didn't get water. Who's gonna be my water person?
I
Who can
will.
go to the sink and get me some water? Lily, thank you so much. So we have a pause at the moment because we don't have any water, but that's totally okay. Didn't have it in our little
I'm
instructions.
gonna get sunglasses.
You're gonna get some sunglasses for your safety goggles? Okay, no problem. Gloves. So the kit we're using today is called Mel Chemistry Kit. You can order it online from melscience.com. It's nice, fun, relatively simple science to do with the kids. And it comes with a nice starter kit that has all the things you need to get started, and every month they send you a packet along with 2 inserts for protocols. You can download the app as well to follow along on your app as you perform your experiments. All right, Lily, you are going to be my person who determines 20 mils of water. So if we look at this syringe goes 2, 4, 6, 8, 10, 12. Not quite 20,
10,
right?
10.
2 of 10. So there's my scientist. She's going to fill that syringe up to the 10 milliliter mark 2 times. You have to pull it up. It's tough, I know. Here, I'll get it started and then I'll let you do it. There you go. Now pull it up to the number 10 so you see the meniscus of the water go to 10. There you go.
Right there?
Let's see. Pull it up. Do you see the water there yet? Okay. There, that's 10, right? Much better.
In here?
Yep. And then dispense it by pushing on the plunger. Very good. And you're going to do that 1 more time. Total of 20 mils.
Mommy,
Yes.
could I pour it in there?
Let's see. Let me see before you do it. Let the doctor check it. Okay, good. Good job. Nice job, Lily. I am going to ask
Me?
Lucy. Oof. We'll clean that when we're done. To give this a stir, right? We're up to that step. Give this a nice big stir, and I'm going to have you do the next step as well because that wasn't too much, right? All right, very good. Then it says, you want to read the next step for me?
What's that?
Right here.
Okay. 2.
Yep.
Prepare a dry
Reagent, mixture,
reagent mixture which will act as a
source.
source of a carbon
Very good. Those were some hard science words there. Prepare a dry reagent mixture which will act as a source of carbon dioxide. So when we breathe in oxygen into our lungs, and what we exhale is known as carbon dioxide. So you can't see it, you can't smell it, but it is there. So in order to make this carbon dioxide, we are going to add 2 reagents. Our first reagent is called citric acid. It has the the molecular formula C6, carbon 6, H8, hydrogen 8, O7, oxygen 7. And we're going to add 1 entire citric acid bottle to our flask. So see here, we now have the flask. So our instructions say we have to make sure we don't put it in here, right? With the red dye, we have to put 1 bottle into this flask. So this is going to be Lucy's job. Lily, you can have the next job. You are going to add sodium bicarbonate. So sodium bicarbonate.
Actually, it's Isabel's turn, right?
Okay. Is it Isabel's turn? I'm sorry. Thank you
Yeah,
for being, I totally forgot. That's very good sharing. All right, so sodium bicarbonate is just a fancy word for baking powder. But it comes in this fancy bottle, and it gives us a molecular formula, Na2CO3. And it says to add how much there?
One bottle.
One bottle to which container?
That one.
The flask, right? Not the cup, but the flask. It's very important that we follow instructions carefully, because otherwise the science won't work. All right, so one whole bottle. Good job. Oh, try not to spill it on the side, right? There we go.
Something fell on the floor.
Okay. We'll put that away for later. Okay, so we have one bottle, two bottle. We'll make sure we recycle those later. We added it to the flask, and then what does it look like they're doing?
It looks like they're like spinning it around.
Okay, so let's spin it around.
Can I do another one? Since this
Yeah,
one-
I might need your help again here. So add some liquid soap, which will cause the mixture to foam. So
Do we have
need.
liquid soap?
I have liquid soap in my box. I just need a bowl that's going to be big enough for
I can-
these two to go in. Okay, can you run
Both of
upstairs?
them?
Not together, just one. So as long as it's big enough to put this one in, because this is where the reaction is going to take place. So we didn't have our next step set up, but our next step, step number 3, tells us what, Lucy?
Add some liquid
Soap.
soap, which will later cause the mixture of form.
Which will cause the mixture to foam. Oh, there's our eruption. So hopefully it'll look something like this. Thank you, Miss Lily, my research assistant, who's kindly went up and got us a cereal bowl. We'll make sure we wash that before we use it for cereal, certainly today. All right, so we need to add one packet, which is a total of 10 mLs of a liquid soap to where? To which container is we going to add it to?
That one?
To that one. So whose turn is it now?
Me.
Oh, she only mixed it quickly. I'm going to let Lily add the soap. You can do the next step. All right, so let me just open this liquid soap up. So this is just like dishwasher detergent soap that we would just get in the sink. So there's nothing dangerous here. It's pre-aliquoted, which means it's pre-measured to total of 10 milliliters. That's what the ml says. And so be very careful. This is with science. We do it slow and steady. We want to get all of that liquid. Yeah, make like a little blip in the top and squeeze it out. Maybe Izzy can help you squeeze from the bottom there to get the soap in.
Wow.
Great job. All right, try to keep it in there. Hold it nice and steady over the top of the flask. One whole satchel.
Is it coming?
I think it's coming. It's hard to know. I mean, we're going off of them that this is 10 mLs. Oops, we're getting it on the side here. Okay, hold up. Hold up a second, Lily, please.
Yeah, I know.
Okay, see, look how we're doing that. We're getting some, we have to just be very careful that we get the solution in the flask and not on the side of the flask, because we don't want to take away from the reaction.
That
right,
only
let's-
I can open it.
Okay, it's probably very sticky now. Just, okay, I'm gonna use the clean end of this wooden dowel to open it up. So if you do this experiment at home, just make sure you either maybe use the filter to go into here, or,
Can we use this?
well, we're kind of past that point. Otherwise, try to make like a little funnel, the funnel to go in the top, or make like a little funnel out of the pack. It's really kind of hard. But you know what? I don't think even if we just get a, whoopsie, even mommy did it. Even if we get a little bit on the side, we'll still be okay.
The next part, it explodes.
Whoa, we're coming up to the good part. All right, so hold on, let me just make sure.
Did I
The
do the
foam,
next part?
this is where the foam comes from, so we want to make sure we got all that foam in there to make our eruption go kaboosh, right?
What if it comes in our eyes?
Well, we got our safety glasses on, and it won't. It's not going to explode. It's going to more like,
Come out.
yeah. All right, so hold your breath for the exciting part. I might take it out just so we can see it. It might be a little messy, but that's okay. So, all right, Miss Lucy Cutter, you have to do what? What is this? What does it say?
Pour the cupping.
All right, so
I can't hold my breath.
hold your breath. Hold your breath. Here, let's wait. Hold on. Hold on. Let's
Do that, yeah.
yeah, so we don't miss any. Oh dear. All right, let's
check it
see it. Here it comes.
It's coming.
Woo! Exploding foam.
Can I touch it?
No, not without gloves on.
Can I
Look at this.
Can I put gloves on?
That's awesome, yeah. Foam eruption. So, what are we seeing here today? This is actually part
Wait,
of...
Mommy, can you give Lucy one of your gloves?
This is
we're
part
gonna
of the
touch it with one
module
glove.
that's called Chemistry of Monsters. It might be a little sweaty because it's kind of actually hot out here in New York today. All right, citric acid and sodium bicarbonate split into ions in water.
Can I touch it?
The molecules of citric acid,
Can I touch it, Mommy?
yes, split into citrate anions and hydrogen ions, while molecules of sodium bicarbonate split into carbonate anions and sodium cations. One carbonate anion reacts with two hydrogen ions to form
This is cool.
carbonic acid, which easily decomposes in water, and the gaseous carbon dioxide, which is what we're seeing, fills the bubbles and makes the soap foam in the experiment. Let's not make a mess, girls. I told you could touch the foam. That doesn't mean we could spread the foam all over the place.
Okay, I'm gonna wash my gloves.
The gloves have to go in the garbage. They don't get washed. The reaction between the acids and the carbonates can be very useful. For example, the same reaction as in the experiment takes place when the fizzing tablets dissolve in the reaction of sodium hydrocarbonate, which is baking soda, and acetic acid, which is contained in vinegar, and that makes the dough airy in baked goods. That was really cool, right, guys? So if you want to try this experiment, Isabel, try not to get it on your dress. Thank you. It is called foam eruption, and it comes as part of the Mel Science Kit for the month of March.
Okay, peace out.
Peace out, everybody.